alaikum dear students. Now this is the fourth lecture in series on projectile motion. So let us do some numericals and try to do number of maximum number of numericals. I mean it depends upon the time. So now the first numerical goes like this. Here is a numerical. You just have a notebook with you and a pen. A body is projected horizontally. A body is projected horizontally from top of cliff. Okay, with a velocity of 9.8 meter per second. What time elapses before the horizontal and vertical velocities becomes equal? Okay, आपको बताना है कि टाइम क्या हो जाएगा जब दोनों vertical and because you know that the horizontal velocity is actually a constant that will not change, but vertical velocity, okay, that actually keep on changing. Its body is accelerating in vertical direction. So the data given is like this. What is data given? Data is velocity. A cliff with a body is projected horizontally from top of cliff with a velocity. Horizontal velocity is given. So Vx is given. It's 9.8 meter per second. But okay, so this is initial velocity along x-axis. So u. One more thing, my dear students, please try to understand it. This question has been set out from this projectile where you have launched it horizontally from some height, and because there is a cliff, so height it's this. The formula for this is height h. The formula for these are the few formulas which may be required. So body is projected horizontally from the top of cliff. It becomes this question with the velocity u is equal to 9.8. So let us first do like this. Body is projected like this. Here initial velocity u. This u is 9.8 meter per second, okay, per second. So we have been told what time elapses before the horizontal and vertical velocities become equal. अगर किसी जगह ये velocity v है तो ये suppose इसका tangent है. This is the vertical component, the horizontal component vx, this vertical component vy. So हमें बताया गया कि किस टाइम पे ये दोनों इक्वल हो जाएंगे, ठीक है. So मैं इसका प्रूफ दिखाऊंगा आपको. फाइन. So like this, we know that v is equal to u plus at. Fine. Along x-axis, this equation becomes vx is equal to ux plus axt. So vx is equal to ux is given 9.8 plus a is 0 because there is no acceleration along x-axis. So vx comes out to be 9.8. Fine. Now similarly along y-axis, my dear students, please keep concentration. Vy will be equal to uy plus ayt. Okay, vy is equal to initial velocity along y-axis. There is no initial velocity along y-axis where the projectile has been fired horizontally. So this is 0 plus acceleration along y-axis is g into t. Fine. So now vy is equal to gt. Fine. That means vy is equal to 9.8 t. 9.8 t. So हमें बोला गया है वहाँ पर कि आपको वो टाइम देना है जहाँ पर दोनों vx as well as vy both components becomes equal. So when vx is equal to vy, ठीक है, तो ये दोनों इक्वेशन बराबर होंगे. तो 9.8 is equal to 9.8 t using those two equations, this and this, those two equations. So this becomes 9.8, 9.8 will cancel out. So it becomes 1 is equal to t. So t is equal to 1 second. So it is after 1 second that the projectile has the same velocity components, vertical and horizontal velocity components equal after elapsing a time of 1 second. This was actually there. Okay, so I will wrap it and go for the next problem. So my dear students, once again we will go for the next problem. Is this a projectile is fired horizontally. Once again, it's a horizontal projectile. Projectile fired horizontally. Okay, So case number 1, fired horizontally. Fine. So fired horizontally with velocity of 98 meter per second, 98 meter per second from the top of the hill, from the top of the hill, from the top of the hill, from the top of the hill 490 meters, okay, from the top of the hill 490 meters high, okay, ये है न्यूमेरिकल. फाइंड हमें क्या बताया गया, फाइंड पार्ट नंबर फर्स्ट, the velocity with which the projectile strikes the ground, the projectile strikes the ground. This is point number 1. Point number 2 जो बताया गया वो ये time taken to reach the ground, time taken to reach the ground. And the third point is the distance of the target from the hill, distance of target from the hill. ये 3 पॉइंट्स हमें बताए गए कि ये प्रूव कीजिए. So my dear students, let us know a projectile is fired horizontally with a velocity of 98 meter per second from the top of the hill 490 meter high. Find the velocity with which the projectile strikes the ground, the time taken to reach the ground, and distance of target from the hill. So let us go this. What is data given there? So what is data given there? So data is a projectile is fired horizontally with the velocity of the initial velocity is given, that is 98 meter per second. This is given. And height, what is the height of the hill? That is given 490 meters. 490 meters. So part number first में क्या find करना है, हम part number first को attempt करते हैं, ठीक है. So the velocity with which the projectile strikes the ground. So we know that this is the horizontal projectile which has been fired horizontally. So this is this projectile, it has been horizontally and its path, its trajectory is parabolic. So the velocity is v is equal to under root u square plus 2gh. This we have derived in the previous lectures. V is equal to under root of u square plus 2gh. So v is equal to under root of u square, u means 98 whole square plus twice g is 10. So let us take it 10 approximately, and it is 490 because height is given 490 meters. So this is equal to, if we will take 9.8 is acceleration due to gravity. So this is under root of, this is 98 whole square, okay, plus this is, so if we will 98 by 10 and 10 cancel, 49. So this is 249, 2 9s are 18, 2 4s are 8 to 9. So 98 whole square, okay, this will again become 98 whole square. This is equal to under root of twice 98 whole square. इसका स्क्वायर एंड रूट कैंसिल हो जाएगा. सो रूट 298. सो v इज इक्वल टू twice this 98 root 2 meter per second. This will be the velocity. So we have got the final velocity. Part number first solved. Okay. So my dear students, let's move to the part number second. Part is the time taken to reach the ground. Time taken to reach the ground. You know what is this time? This is called the time of flight. The projectile which it takes the time to reach the ground is called time of flight. So indirectly it is actually asking us to find the time of flight, and for that we know the equation is t is equal to under root of 2h by g. So now proof goes like this: t is equal to under root of 2h by g. Everything is given there. So t is equal to under root of 2 into 490 divided by 9.8. Okay. So here it is. Then it's 10, 490, it's under root of 9800 divided by 98. It's cancelled, it's under root of 100. This is nothing but 10, okay, 10 seconds. So, time of flight is 10 seconds for this projectile. Okay, we have solved it this numerical as well, this time of flight as well. Okay, so now let us move to the part number 3rd. It is asking distance of target from the hill. What is the distance of target from the hill? Because hill from where it has been launched, I mean target where it hits. So, this is nothing but range. So, we are actually indirectly asked you to find the range. So, for range we know formula is r is equal to u under root of 2 h by g. So, r is equal to u means initial velocity, that is given 98, and we have calculated this under root 2 h by g. In case of the previous question it is 10, it was time of flight 10. So, r is equal to 980 meters. So, this is the range. So, we solved this question as well. Got it, my dear student? Okay. So, let us rub it again. So, let us tackle a new numerical. So, we will see how many we can do. So, one more numerical. A bullet fired at an angle of 15 degree, fired at an angle of 15 degree, okay, with the horizontal hits the ground, with the horizontal hits the ground, it is the ground 3 kilometers away. Okay, this is the 3 kilometers away. Fine, this is written in the numerical. Can we hit a target at a distance of? Can we hit a target at a distance of 7 kilometers? Can we hit? ये देखिए, a bullet fired at an angle of 15 degrees with the horizontal hits the ground 3 kilometers away. So, something like this. So, a bullet, this angle is 15 degree, it is given with the horizontal के साथ. So, this is actually a projectile which is fired at an angle with the horizontal. This one, that all the formulas are derived. Actually, in my previous lectures we have derived it, and then it hits the ground 3 kilometers away. So, it hits the ground at this 15 kilometer, it hits the ground 3 kilometers away. So, this is nothing but it is 3 kilometers up to this, the range is this at 15 degree. Can hit a target at distance of 7 kilometer. So, can we hit a target at distance of 7 kilometers? I mean with this projectile. If this projectile is has been fired with this angle 15 degree, it has 3 kilometers. Can we hit the target which is at 7 kilometers? I mean if we need to change the angle, how much maximum we can go, how much far away we can go. So, let us do one thing. We have this formula for range, r is equal to u square sin 2 theta. So, here I can do like this. Range is u, this twice u sin, this u square sin theta, sorry, u square sin 2 theta divided by g. This is range. Okay, with this formula we know. Okay, fine. So, now this r is equal to, this is u square sin theta is given 2 into 15 degrees because theta is 15 divided by g. Let us calculate the range. So, r is equal to, range is given there. So, this is 3 kilometers, range is 3 kilometers. Okay. So, let us keep it in 3 kilometers as well. This is initial velocity, this is u square sin 15 into 3 is 30 degree. So, like this. So, it is divided by g. So, 3 is equal to u square by g sin 30. Okay. So, sin 30 is 1 by 2. Okay, 1 by 2. So, this means 2 3s are 6. This means 6 is equal to u square by g. Okay. It means u square by g is equal to 6. Do you know u square by g? There is a formula that is called the r max. Maximum range we have calculated this, r max is equal to u square by g. This formula for such a range, u square by g. So, this u square by g is nothing but this is our max. Okay. So, we got our max is equal to 6 kilometers. Okay, you know, because u square by g is maximum range. So, maximum we can go up to 6 kilometers maximum. If we will go the maximum for 6 kilometers, we cannot hit, I mean at 45 degrees, this will be the range 6 kilometers maximum. We cannot hit beyond 6 kilometers. The numerical is, can we hit a target distance of 7 kilometers? No, we cannot hit, because the maximum range we can achieve is 6 kilometers only. Okay. Okay, dear students. So, let us see whether we can go for next numerical. So, try to attempt another numerical as well. So, let us do one more numerical, is that an aircraft flying horizontally horizontally 2 kilometers with the speed of 200 meter per second, then passes directly overhead an anti-aircraft gun. Okay. At what angle from the vertical? At what angle from the vertical? The gun be fired so that a shell with muzzle speed 600 meter per second, may hit the plane. ओके, ये हमें बोला गया है. फाइन, हमें निकालना है किसी तरीके से. Fine, my dear students, let us try to do it. And suppose we will perform this one first, and then we will go for next one. An aircraft flying horizontally 2 kilometers. So, let's try to understand this numerical. It's like this. Here an aircraft, say suppose this is an aircraft, its speed is 200 meters per second. 200 meter per second, like this. Fine, passes directly overhead an anti-aircraft gun. So, this is anti-aircraft gun, say suppose like this, anti-aircraft gun. At what angle from the vertical? So, this is the angle, vertical के साथ, ना कि horizontal के साथ. ये हमें बोला गया कि किस एंगल पे रखना है. The gun be fired so that a shell with muzzle speed, shell with जो यहाँ से स्पीड निकलेगी उसकी स्पीड है 600 meters per second, 600 meter per second with muzzle speed may hit the plane. किस टाइम पे? फाइन, तो हमें देखिए एक चीज़ है ना, ये जो है ये लीनियर डिस्टेंस निकालेगा. जो जहाज ऊपर से है, एयरक्राफ्ट ऊपर से है, it will actually traverse a linear distance, but at the same time, if suppose this is the velocity u, then here it is u sin theta. Okay, u sin theta. Here it is u cos theta component, because along the base it is cosine component and along the perpendicular it is sine component. So, now u is given, u is equal to 600 meters for muzzle speed. Okay. So, suppose it has two components, one u sin theta, one u cos theta. U cos theta will actually build up at heights, but u sin theta take it linearly in the forward direction. So, let us see the linear distance covered by this. So, you know speed is equal to distance by time. speed is equal to distance by time, you know. So speed is equal to distance by time, fine. Then distance is equal to speed into time, speed into time is equal to distance, fine. So with this formula we can say, here the distance traversed by the aircraft is v into t, v is speed, that is 200 meters per second, into time वो हमें नहीं पता है, okay, is equal to distance, say some distance, it's actually x distance इसने cover कर दी, ठीक है. Similarly ये है इसके लिए स्पीड एयरक्राफ्ट के लिए. तो ब्लेड क्या करेगा, ब्लेड भी स्पीड इंटू टाइम क्या होगा, उसकी स्पीड जो है वो है u sin थीटा, u sin theta, that means u is 600, that's 600 sin theta, 600 sin theta into t into, okay. So what do we have to calculate, at what angle, fine. So this is equal to into t, that's equal to x, same distance. देखो my dear students, with this speed, velocity into time, it actually suppose traverse some distance. Here velocity into time, it also traverses linear distance because of the sine component only, not the cosine component. So the u sin theta into time t, it actually completes the same linear distance x. So 200 into t is called x, 600 t into x. So from these 2 points we can actually write down this both are equal, therefore 200, or we can write down 600 sin theta into t is equal to 200 into t, fine. T and t cancel, so sin theta and 2 zeros are cancel, 2 ones are 2 threes are, sin theta is equal to 1 by 3. If sin theta is 3, then I can what we can do one thing, here I will show you. If sin theta is this 3, then theta is equal to sine inverse of 1 over 3, okay, like this. So theta is equal to approximately I can say 19.5 degrees. So this angle is 19.5 degrees. You know, when an aircraft is going with a speed of 200 meter per second, then we aim the gun which is firing a shell with a speed of 600 meter per second, we have to aim it at an angle of 19.5 degree with the vertical, only then it can hit the target. If suppose we need to hit the target, we can only hit taking these equations into consideration, okay. Now somebody will tell us what is the maximum speed for this aircraft so that it will be safe, मतलब ऐसे ना इसमें तो हिट हो जाएगा, इस एंगल पे हिट तो हो जाएगा, बट the driver of that plane, he can say pilot is, so pilot can actually be well knowledgeable, so he using his knowledge we can see that he has used this particular gun, so how far it can reach, how maximum height it can reach. So if we fly above that height, the muzzle will not touch it, muzzle will not hit it, okay. So the point is we need to find out then, if somebody will ask us what is the safe speed for the plane to fly, okay, so that the muzzle will not, the shell of the muzzle will not hit it, okay, the shell will not hit it. So what is the safe height? Let us calculate first the maximum height. You know, maximum height is equal to, we know the formula for maximum height, it is u square sin square theta, u square sin square theta divided by 2g, this for maximum height. But do remember my dear students, this maximum height is for that which is making actually theta angle here, but here what we will do, we have calculated this angle, this is with respect to the vertical, then this angle becomes 90 minus theta, okay. So we need to change this angle by 90 minus theta, only then this formula is valid, because why we have derived this equation where we took angle with the horizontal, but this time it is with vertical, so this remaining part is 90 minus theta, so we need to replace it by 90 minus theta. So h is equal to, when we replace it 90 minus theta, so h is equal to u square, then sin square 90 minus theta, okay, ये आएगा divided by 2g. So the maximum height in this case will be u square cos square theta, okay, 90 minus theta is cos square theta, because sin 90 minus theta is cos theta, but there is a square, so this will be the formula, u square cos square theta divided by 2g. So let us calculate the safe height, okay. So we will go for the safe height now. So h is equal to u square cos square theta. So let us calculate it like this, it's 1 minus sin square theta, okay, cos square theta is 1 minus sin square theta, sin square theta plus cos square theta is equal to 1, ठीक है. So 1 minus sin square theta is cos square theta divided by 2g. So we can write this equation like this. So h is equal to u square, then u square is the initial the velocity, okay, the velocity with which this has been projected, so maximum height this u, okay, u sin theta. So this is around 200, so 200 whole square, this is 1 minus sin square, sin theta is 1 by 3, sin square is 1 by 9, so this is 1 by 9 whole divided by 2 into g. So let us take g as 10. So approximately you will come out with this is approximately because we are running short of time, this is 16,000 meters. So h is equal to 16 kilometers, something like this. So we will get this maximum height as 16 kilometers. So if we will hit with that muzzles, we actually fire a shell that is having 600 meter per second, it can maximum reach up to 16 kilometers. If an aircraft will fly above 16 kilometers, it will never hit it. The safe height is 16 kilometers. So I hope you have understood it. If any doubt, you can drop me a text on my WhatsApp number 97970123446. I repeat, 97970123446. Thank you very much, my dear students.